Okay, let's take a look at example 7. After taking a look at how do we find the point of intersection between a line and a plane, now we take a look at how a line can be parallel to a plane where they do not intersect. Alright, so example 7, there's a line with this equation, there's a plane with this equation. Show that line is parallel to plane, determine whether L lies in pi. Alright, what does L lies in pi mean? Means that if it lies entirely in, if L lies in pi, it means it is this case where this is a plane and the line, all the point on the line lies in the plane. Alright, never mind, let's do one thing at a time. We need to show that L is parallel to the plane. Okay, there's only one way to do it. This is the normal vector. Correct? This is a normal vector of the plane. Let's look at this diagram here. This is the direction vector of the line. This is the normal to the plane. If I can prove that the direction vector, this is the direction vector of the line, is perpendicular to the normal, then for sure these two, the line and the plane, are parallel. Alright, so we'll do this. We take dot product of the direction vector and the normal vector of the plane. Direction vector of the line, normal vector of the plane. We dot, realize that this is minus 3 plus 0 plus 3. Oh, it is equals to 0. It means that the normal vector, look at the figure here now, the normal vector is now perpendicular to the direction vector of the line. So clearly this line is parallel to the plane, this plane up here. Done. But if you prove that they're parallel, this is the second part, determine whether L lies in pi. Because there are two cases here. One is you have a plane, alright, you have a plane, they're parallel like that. But they do not have any common point. Second case is where they lie on it. That means they have all the common points. All the points on the line lie on the plane. So we got to determine which case is it. How do we do it? All we need is to check this point. 2, 1, minus 1. 2, 1, minus 1. Let's check whether 2, 1, minus 1 lie on the plane or not. Whether it lies on the plane or not. Okay, how do we check? We substitute 2, 1, minus 1 into the equation of the plane. So, we'll do this. 2, 1, minus 1 dot minus 1, 0, 1. Sub onto the left hand side of the equation of the plane. If it's equals to 1 here, means it lies on the plane. If it's not equals to 1, anything other than 1, then it doesn't lie on the plane. So we check. This is minus 2, minus 1. Sorry, no space. Equals to minus 2 minus 1, which is minus 3, is not equals to 1. That means this point doesn't satisfy the equation of the plane. That means this point does not lie on the line, or the plane, sorry. So it lies on L but does not lie on plane. So I think it's obvious now that the line, the conclusion is important. Now the line does not lie in pi 1. All we need is to check one point. You don't need to check 10 points. Why? Because the first condition is important. The first condition is that the line and the plane are parallel. Figure head again. Parallel, either this or this. Either no points are common or all the points on the line lie on the plane. So all we need is to check one point. So we happen to check one that we know. It need not be this one. It can be this one. It can be this one. It can be this one. It doesn't really matter. Of course, we take the most convenient one. We took 2, 1 minus 1. So done. This is the conclusion. All good? Now let's take a look at example 8. Example 8 is the case where, no surprise, that this is the case where all they are parallel and yet all the points on the line lies on the plane. Okay, that means the line lies in the plane like that. Lies on every single point on the line lies on the plane. So let's see. You have a line equation, you have a plane equation. Show that L lies in pi 1. There are two methods I need to show. It's really up to you which one you prefer. Okay? I shall not give you my preference. You explore both. Okay? So, first method. It's similar to what we see in example 7. First method is I determine that the direction vector of the line is perpendicular to the normal vector of the plane. So this dot this dot this equals to 0. You realize it's 0. This step is similar to example 7. Right? Then we say, oh, okay, it is parallel. So we conclude that this is parallel. Right? Let's continue the solution on the right hand side. So again, it's similar to example 7. This time we check. We check that this point 2, 1, minus 1, you substitute into the equation of the plane, which is minus 1, 0, 1. You get minus 2, minus 1. You get minus 3. So we check. Correct, minus 3. That means this specific point lies on the plane. So if one point lies on the plane, if this point which is on the line lies on the plane, it must mean that every single point on the line lies on the plane. Because first condition is that they are already parallel. Right? They are already parallel. Since they are figure here again, parallel, and if I say one point lies on the plane, every point must lie on the plane. Shown. Therefore, L lies in pi. Or you can look at method B. Okay? Method B is this. Let's go back to the equation. This is equation of the line. This is equation of the plane. Method B works like this. Right? Method B works like this. If I can somehow show that for whatever t I sub in, this part I substitute in, no matter what is t I sub in, it will always be minus 3. Then for sure, all the points on the line lies on the plane. And therefore, line lies in plane. Let me show what I mean. That means this. Sorry. Oops, sorry. I'm going to substitute the equation of the line onto the left into the left hand side of the equation of the plane, which means this. Open bracket. 2, 1, minus 1. This is the left hand side plus t. 3, 1, 3. This is the equation of the line. Dot minus 1, 0, 1. Yeah, sub into the plane. What do I get? Okay, I use the distributive property. I distribute like that. You realize that means I take this dot this first. I take this dot this first. Alright, I get a minus 2, minus 1, plus t, minus 3, plus 3. In the end, I realize that the t goes, I will get minus 3. So, see again, this is the equation of the line, correct? This is the line. You sub into the plane, right? The plane has equation this. you sub into the left hand side of the equation of the plane. We don't assume it's minus 3 first, you sub in. You realize, you do get minus 3. What does it tell us? It tells us that for whatever t I put in, all the position vectors, all the points on the line lies on the plane. So if all the points on the line lie on the plane, then clearly we conclude that therefore L lies in pi. Yes? Example 9 is for you to read on your own. I don't think we need to go through. You can slowly pause the video, digest it, and then we can carry on next. Yep. Pause the video, or that's the end of the video.